your number sequences as your heading. Okay, we are 90L, 2, and it is Monday. I will not be at school on Friday, so I will leave a worksheet for you to do, which will just be questions based on everything that we do this week. Where is my Zoom? There we go. Okay, so number patterns or number sequences, whichever you want to use, means exactly the same thing. So what we're going to do today is we're just going to write down all our notes, and then from tomorrow onwards we're just going to practice, practice, practice. Okay. I just want to make sure of the notes that we write, that it is exactly the same as the other group. There we go. Okay, so we know that there are two types of number patterns. It's not the only ones, but are the two that we deal with in junior phase. It is my arithmetic pattern or arithmetic sequence and my geometric sequence. There are definitely others, like the quadratic sequence, which you learn in grade 10, and the other types of sequences you learn in matric and university. So we're just going to start with some terminology, just to recap what all these things mean as we hear them. We are going to talk about a term value, and this is referring to the T with the little n at the bottom. And this is always the value of the actual number at that position. Which means we actually need to know what position is. So term position in the formula is referring to the little, not the little n, but the n variable, the position, of the number in the sequence. So we're talking about first, second, third, fourth place, or fifth place, or sixth place. Or the term, the fifth term, sixth term, okay? The place on the podium. So, first, second, third, that kind of thing. Then we're going to go into the terminology of what makes these two patterns different. How do they differ from each other? So we need to know what difference means in terms of number patterns. The difference is when two adjacent terms are minus. What that looks like, for instance, is T2 minus T1 as your example. Or T3 minus T2, or T5 minus T4. Always two numbers right next to each other. So that's just a difference. We still need to know what a constant difference is. Okay, so it's the same difference between all adjacent terms. For an example, T2 minus T1 is exactly the same as T3 minus T2, which is exactly the same as T4 minus T3, which is exactly the same as T5 minus T4, and so on and so forth. All those differences are precisely the same. Okay, two more bits of terminology. We need to know what a ratio is. A ratio is a division, so a fraction, but particularly of two adjacent terms. An example would be taking my second term and dividing it by my first term. And lastly, we need to know what a constant ratio is. It is the same ratio between all adjacent terms. For example, T2 divided by T1 must be equal to T3 divided by T2, or T4 divided by T3, or T5 divided by T4, etc. Okay, is anyone still busy? Okay, I'll move it up so that the ratio is still seen. Okay, the first one that we're going to finish all our notes on is my arithmetic number pattern. We can also call it a linear number pattern, but we generally use the word arithmetic. Arithmetic sequence or arithmetic pattern. I'm going to say AKA linear sequence. How do we know that it is in arithmetic? We have an identity check. We check the constant difference. So we are checking that T2 minus T1 is equal to T3 minus T2. If it is true, then it is an arithmetic sequence. And you have just found D. Two o'clock every day until your holidays, except Wednesday. Wednesday will be shorter because there's no assembly. Once we know that it is arithmetic, we have found the D value. Where are we going to put that D value? Well, we're going to put it into our formula. Tn equals to A plus n minus 1 times that D that you calculated. Putting the formula in a block because you have to learn it off by heart. You will not ever be given it in grade 9. Just recapping what those different variables mean. Tn we found in our terminology, it is the value of a term. A in the formula is the value of the first term in the sequence. N is the term position that I am referring to. And D would be that constant difference that we calculate. So what do we do if there is no constant difference? What happens when I do the two minus sums, but they are not equal? Well, that is when I check my geometric sequence. There is no other name, it's just called a geometric sequence. And its identity check is checking the constant ratio. Okay, is everyone finished with the arithmetic notes? Taking it off of the screen so you can see this in full. So we're checking the constant ratio. We check calculate T2 divided by T1, calculate T3 divided by T2, and compare those answers. If they are the same, we have a geometric sequence. If we have a geometric sequence, we therefore have my constant ratio of T2 divided by T1. What do we do with that R? We substitute it into the geometric formula. Once again, in a box because you need to know it off by heart. Lastly, what do all those things mean? Tn is still my term value. A is still my first term value of the sequence. R is now my constant ratio. And N is still my position of my term. The last bit of theory we're going to write down is the types of questions that we could receive and what it is we're supposed to do. And we're going to do it in a table format, and then we're going to practice. Anyone busy with the board still? Okay. So your table only has 2 columns, so you can just split your page down the middle. It will probably be quite some space, and about a page, maybe more, depending on how much you write, how big you write. Okay, so my first column's heading is question. What does the question ask us? And my second column's heading is what is it I'm expected to do? So question and do. Splitting my page down the middle. Anyone still busy with the last notes on the geometric stuff? The Tn, A, R, or N. Going, and gone. Okay. So since we have 2 equations that we have to memorize, obviously filling out those equations, finding the true equations, is a question that I can ask. And I can ask it in 5 different ways. So I could say find the general term, or I could say find the general solution, or I could say find the nth term, which means just If I don't actually have a value for n, I just use n itself. I can also call it finding the formula. I can also say find the rule. So all of these 5 sentences are 5 different ways to answer exactly the same question. So that's my question, but what am I doing? I am finding the values of the respective variables in the formula. So now this will depend on whether I'm dealing with arithmetic or geometric. In arithmetic, it means I'm looking for A and for D. In geometric, I'm looking for A and for R. Since I'm not talking about a specific term, I cannot find anything that relates to the n. That means I can't find n, it means I can't find Tn, because Tn has got an n in it. So those variables remain Tn and n. But A and D, or A and R, need to get values. So we'll just make a note here. N and Tn remain N and Tn. They do not get values if my question is asking for the formula. So once I have the formula, I know the values of A and D or A and R, I can now go further and ask questions relating to position and questions relating to term value. So my first question will almost always be, what is the formula? What is the rule, the general solution, whatever words I choose to use. Then I will go ask stuff like, find the value of the something term. Find the value of the term. Now what is given to you in this little block here is the position. So how do I know that the position is being given? Well, I look for those podium words, the RD, ST, something that tells me that it's on a podium, like we do with athletics. Okay, so we are looking for those kinds of words. Third, second, first, 51st, 201st. So in other words, they are giving me the n. Since they give me the n and they are asking for the value of n, I need to solve for that value. So I'm solving for Tn. How do I do that? by subbing in n into my formula. Okay, I'm going to start a new table because I've run out of space on that page. So you can rule a line after that for your next question. At what position do you find? So the question was said, what position do you find? Whatever the number is. Or they could say, find the position of whatever the number is. So they're giving you term values. Given term values, which is your Tn. Your Tn gets cut and the number gets pasted. So that means we need to find the position, which is your n. Find position, which is your n. Actually, don't write that there. Write it here. Solve for n. How do we do that? By subbing in what we have into the formula. So if I get given Tn, I put it in, I solve for n. If I get given n, I put it in and solve for Tn. So how do I know that it is the value given to me? There are no podium letters or podium words. So that's the third type of question I could ask, and there's one more type of question that I can ask. Okay, so my last type of question, does this number exist in my pattern? Does this number exist in the sequence? Is this number part of the sequence? Those kinds of questions. I'm giving you the term value. I want to know, is it part of the sequence? How do we answer yes or no? Well, firstly, we have to solve for n by subbing in Tn into my formula. But we need some kind of criteria to be able to say, yes, it is in the sequence, or no, it's not in the sequence. So we do that in the following ways. So we check the answer of n. For arithmetic, n is a whole number, then yes. If n has a decimal, then no, it's not part of my sequence. So if I'm dealing with an arithmetic sequence and I can find n with no decimals, yes, it is part of my sequence. If I get n but it does have decimals, then no, it's not part of my sequence. Then for geometric, very similar. But we are going to solve for n, okay? So if I have the same prime base found, then yes. If I cannot find a prime base, then no. In other words, if I can solve for n, yes. If I can't solve for n, then no. So can solve for n would be a yes. Can't solve for n would be a no. And if you can identify those questions, follow what you must do. This will not be a problem for you. Yes. Yes. Okay, let's do a work example together. Okay, can I take this off the board? Anyone busy? Okay. As soon as I'm finished writing this down, we're going to take it off the board, so please hurry up. Okay, so our first example, I'm not saying what it is, and I have 4 questions based on the sequence. Okay, so I'm giving you 5, 8, 11, 14, 17, dot, 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 which means it continues. The 4 questions are: determine the general solution, determine the 53rd term in the sequence, which term in the sequence is equal to 62, and is 96 a term in the sequence. So we're going to work through all 4 of those questions together. And every single question you're going to receive is going to be very similar. Are we ready? Please have to send this email to the parent. So, what am I asking you to find in my first question? Finding the general solution means doing the formula, okay? Which means we need to know, is it arithmetic or is it geometric? And we always start by checking arithmetic first. So I'm going to look for T2 minus T1. That is 8 minus 5. So I'm looking for the second position minus the first position. 8 is my second position, 5 is my first position, and my answer is 3. But I need to check the constant difference. So I need to check another 2 terms. So I'm going to check the third position minus the second position. My third position is 11. My second position is 8, which is also positive 3. The answers are the same, therefore it is arithmetic, and my D is positive 3. Since it is arithmetic, I immediately write down what the arithmetic standard formula is. And now I substitute the stuff that I know. A is my first value, which was 5. My general term, I don't have a specific position, so n stays in. And D is what I calculated, it is times 3. Okay, I just need to take that out of the way for a bit. But I cannot leave it that way. I need to give the most simplified form of an equation, which means I'm going to multiply out those brackets. 3 times n and 3 times negative 1. And lastly, just tying it all together and simplifying our equation. 5 minus 3 is plus 2. So there is my general solution. I can take any position and find any term because of that formula. Now, all my questions that I'm going to answer forthwith is based on that equation. So my next question was, determine the 53rd position in the sequence. What have they given me, and what have I got to solve for? And we'll pick that up tomorrow. Okay, so tomorrow we will look at that. Yes, Melissa. No, period 3.